Let's take a closer look at the Sprout stack. Like Niagara, the backbone of Sprout generation is the execution stage. These are collections of modules that are executed in sequence to simulate the Sprout's growth and generate its mesh elements. As you can see here, we start with an initialization stage. We then run through a loop of spawning and updating, or growing branches. We spawn leaves from any created elements, and when all elements have been generated, we create their meshes. We can filter execution stages from the stack using these buttons. The execution stage header shows the name of the execution stage, and a button for adding new modules to the stage. Modules are behaviors that we can combine to control the simulation. Modules read from a number of inputs, and then either generate new elements or read and write to attributes. Each execution stage allows us to add or remove modules, but some modules are considered required. These are primarily spawner modules, such as the branch, leaf, and mesh spawners. This module, BP Grid Spawner, is an example of a required module. Notice that it can't be deleted or moved. We can replace required modules by clicking this drop-down arrow. For now, we'll stick with the Grid Spawner. If we open the blueprint for the Grid Spawner, we can see that it reads from its inputs, writes to some outputs, and performs additional behavior. In this case, it's spawning new turtles. The rest of the modules in this execution stage are arranged and executed in order. In this stage, we first set initial values for some of the new branch's attributes. We then apply some random rotation. We'll add another module using the plus button next to the execution stage and select Kill Turtles from the drop-down of available modules. This will remove branches from the simulation based on their attributes. We can move modules up and down the stack by dragging them or by using these arrows here. Modules can be removed using this trash icon. They can be enabled or disabled using this checkbox. Note that the order of modules is important. Our results will be different if we edit the turtle's position before the Kill Turtles module rather than after. Modules may also have outputs. These are variables that were written to during a module's execution and which are available to any modules in this execution stage. We can show these from the Stack Options menu, selecting Show Script Outputs. Now, a new section has been added to our BP Grid Spawner showing its outputs. To see how this works, let's change the Kill Turtles module to Cull Turtles based on the output variable column index. As we can see, a module's inputs are listed in the stack. You can set these inputs directly, or set them from attribute values by dragging from the parameter palette. Also, we can calculate values for these inputs using dynamic inputs. Where modules perform behavior and change attributes, dynamic inputs simply take in a number of inputs and calculate a single output. These inputs can be set exactly like module inputs, which allows us to combine attribute values and dynamic inputs for more complex behavior. There are a few actions that can be performed on inputs in the stack, depending on the input's value. For all inputs, the drop-down arrow is used to change the input's value, and we have an icon for resetting to default. We can log an input's value during execution using this bug icon. For vector variables, we can click the world icon to create a world space edit widget for this value. If we click it again, the widget will appear in simulation space, which basically means local to the Sprout actor. Dynamic inputs can have custom visualizers as well. Now let's take a look at the parameter palette. These parameters are handles to useful data on elements in the simulation, and we've used quite a few already. They are separated into a few namespaces. Turtles, branches, and leaves all refer to elements in the Sprout simulation. Engine parameters give access to useful data that is available at all stages, like the actor location. The context parameters are given meaning by the current module. These parameters may have different values depending on the module they are being used in, though they are often a convenient way to access information easily. Parameters in the user namespace will be exposed on instances of the Sprout. You can see that we have exposed two variables, rows and columns, which we are using to change the bricks we are spawning. We can set the default values of user parameters in the Sprout data section of the Sprout stack. If we look at the details panel for this Sprout actor, you can see that we have set override values for the parameters. We can edit these to change a given instance, and we can easily reset these to the source value by clicking Reset to Default. Notice the icon is changed to indicate that the value is not overridden. We can also create parameters and attributes in other namespaces. This is often useful for caching information between execution stages. For example, let's make a new branch parameter, set its type to int, and rename it row index. Now we'll cache the grid spawner's row index output variable. If, let's say, in the mesh generation stage we wanted to set a brick's vertex color using its row index, we can now do so.